Dear students, let's continue with our discussion on polygons. Take a look at this question here. A regular polygon with n sides has each exterior angle measuring at least 30 degrees. If each exterior angle is an integer, the number of possible values of this n is how much? That is the question. So for answering this question, quickly recall the sum of all exterior angles of a polygon irrespective of the number of sides. That corresponds to 360 degrees. So this is the concept which we are going to consider for answering our question. So if I am considering a regular triangle, which means I am considering an equilateral triangle. Okay. So sum of all the exterior angles of that equilateral triangle, it will be 360 degrees. So the measure of an exterior angle, that corresponds to 360 divided by 3. And I can say that comes to 120 degrees. You just take an equilateral triangle, you can see what I am saying, it is true. Okay, each angle, for an equilateral triangle, it measures 60 degrees, right? So, if I am going to consider the exterior angle here, say the exterior angle at this point, if I am going to consider, you can say this exterior angle, this corresponds to that 120 degrees. And same will be the case with all the other remaining two exterior angles as well. Okay, so that if it is a regular polygon, and then it is the number of sides, the measure of an exterior angle, it will be 360 upon n. Okay, so let us consider a regular quadrilateral. That is nothing but a square. So sum of all the exterior angles, it is 360 degrees. Like that, we have 4 in number. I can see 360 upon 4, measure of an external angle or an exterior angle, it is equal to 90 degrees. What can we infer here? As the number of sides it increases, the measure of that exterior angle, you can see that it keeps decreasing. The measure of an exterior angle, you can see that it keeps decreasing. Okay, let us consider pentagon. So when I am considering a regular pentagon, measure of an exterior angle, it will be 360 degrees divided by 5. I can say that corresponds to 72 degrees it will come. Got it? Likewise, if I am considering a regular hexagon, for a regular hexagon, we can see that measure of an exterior angle, it will be 360 degrees divided by 6, and that is equal to 60 degrees it is coming. Right? So I can see that here, the possible values for n, when I am considering, it could be 3, it could be 4, it could be 5, it could be 6. But please note, we cannot consider 7 here. The number of sides equal to 7 here. You know why? Then measure of an exterior angle, it will be 360 degrees divided by 7 it will come. But 360 by 7, we cannot have an integer value for that exterior angle, right? Because they have mentioned in the question that each exterior angle is an integer, they have told you. If n is equal to 7, 360 by 7 is not an integer, so I cannot consider 7. But look at 8, 360 divided by 8. If n is equal to 8, if I am considering 360 divided by 8, you can say that is equal to 45. So 8 can be considered, right? Likewise, 360 divided by 9, if I am doing non-again and considering, I can see that that also results in, it comes as 40, right? So 9 can also be considered. Of course, 360 by 10, if you are doing, you can see that the measure of an exterior angle, it will be 36. So 10 is also possible, right? 11 is not possible because 360 by 11 will not give you an integer value associated with an exterior angle. So 360 by 11, it's not giving an integer value, so 11 is not possible. 12, if you are considering 360 divided by 12, okay, duodecagon. 360 by 12, you can say here the limiting factor comes, I can say measure of an exterior angle, you can say that will be 30 degrees. So 12 is possible. Further, if you are going to increase the number of sides and if you're going to make it 13, 14, etc., you can see the measure of an exterior angle, it is going to become less than 30 degrees. But in the question, it is said the value, it should be at least 30 degrees, right? So we can think about the possible values for n as 3 or 4 or 5 or 6 or 8 or 9 or 10 or 12. So how many values we can think of? 1, 2, 3, 4, 5, 6, 7, 8. We can see that altogether the number of possible values for n, I can say the answer, it is equal to 8. 8 values are possible. And that's how the calculation it is made. Okay. Now let's consider the next question. How many of the following statements are true? That is the question. So A, B, C, three conditions they are given. Let's look at A. Each interior angle of a regular pentagon, it is 108 degrees. It is given that it is a regular pentagon. Okay, so all the internal angles will be equal in measure. So recall the sum of all internal angles or interior angles for a polygon with n sides, it will be 180 into n minus 2. Okay, so here n it is equal to 5. So sum of all the interior angles associated with this pentagon, the regular pentagon, when we consider, it will be 180 into 5 minus 2, that is equal to 3. I can say that total, it will be equal to 540 degrees. Please note, this 540 is nothing but sum of all the internal angles. That is coming here as 540 degrees. So the measure of an internal angle will be equal to 540 divided by 5, and that comes as 108. So the measure of an internal angle associated with a regular pentagon, 108 degrees, it is true. So the first one, what we are seeing here, this has to be true. Got it? Now let us look at the second point. Thrice the exterior angle of a regular decagon is 108 degrees. Okay, so let us consider for any polygon, like we saw, the sum of all the exterior angles of a polygon, any polygon for that matter, 360 degrees. So here I can say sum of all this exterior angles in this case. Okay, we know that that is corresponding to 360 degrees. Got it? But it is a decagon. So the number of sides, it is equal to 10. So the measure of an exterior angle, one exterior angle, that will be equal to 360 by 10, 36 degrees it will come. This is the measure of an exterior angle. Okay. Now, thrice this value, that is 3 times 36 if you do, you can say that will come as 108. So we can say this corresponds to 108 degrees. Thrice the exterior angle of a regular decagon, we can say that is 108 degrees. That is true. So the second point presented here, it is also true. Now, let's consider the third point. the number of diagonals in a regular dodecagon, that is the number of sides, it is equal to 12. It is twice that of a regular nonagon. Number of sides for a nonagon, and it is equal to 9. Okay. So, in general, the number of diagonals for a polygon with n sides, it will be nc2 minus n. So, for a regular dodecagon, when n it is equal to 12, the number of diagonals, it will be 12c2 minus 12. And how much this comes to, that 12c2, that is 12 into 11 divided by 1 into 2, that is 66, minus 12, it comes as 54. Okay, that is for the dodecagon. Nonagon, n it is equal to 9. So the number of diagonals will be 9c2 minus 9. What is 9c2? 9c2 is 9 into 8 divided by 1 into 2, which is 36, minus 9, you can say that is equal to 27. Now, look at the condition here. The number of diagonals of the number of diagonals in a regular dodecagon, that is 54, is twice. 54 is twice that of 27. You can see that 54, it is equal to 2 times 27. What the condition that is mentioned here in the third point, it is also true. So we can see that here, A it is true, B is true, C is also true. We can say all three statements are true. Okay, so that's for this question here, question number 7. Okay, now let's consider the next question. In the figure ABCDEFGH, it is a regular octagon. You are asked to find the measure of angle AFG. Okay. So, for answering this question, first, let us find out the sum of all the internal angles, interior angles of this regular octagon. Octagon, number of sides, it is equal to 8. So, sum of all the internal angles, it will be 180 into n minus 2. And that comes as 180 into 8 minus 2, that is equal to 6. So, 180 into 6, when I do, the total comes here as 1080. So, that is nothing but the sum of the internal angles, all the internal angles associated with this octagon. 1080, 180 into 8 minus 2, 180 into 6, 1080. So, from this one internal angle, okay, one internal angle, if I am going to consider, I can see that value, it will be 1080 divided by 8. I can see that that is equal to 135 degrees. Got it? I can say this is equal to 135 degrees. Now, if I am observing this diagram, they are asking me to find what is the measure of this AFG. What is this measurement? That is the question. Okay, so let me highlight it here. This measurement is what they are asking us. I shall highlight it with red color. Okay, this measurement is what they are asking us. But if you observe here, this A, F, I shall draw it with red color, A, F, G, here, H, and this A. If I'm going to draw them, can't we not see that it's a quadrilateral? Let's forget whether it is, let's not bother whether it is trapezium or what. Let's not bother about it. You can see that here, 1, 2, 3, 4. 4 sides we can see. Sum of all the internal angles associated with a quadrilateral, that is equal to 360 degrees, right? So this angle A plus angle F plus angle G plus angle H, the total it should be 360 degrees, right? But here I do see one internal angle 135 degree here, another internal angle that also 135 degrees here. Yes or no? And if I am observing closely, can I not see that this angle AFG and this angle FAH, because the same line with the side, the same line with another side, it is coming. Can't we not see that those two measurements will also be the same, right? Because if you're looking at it, it's AF, the line, it is inclined to the side FG, it is a regular octagon. So all these measurements are equal, right? So same way FA is there and it is inclined to AH, the side. It's the same line with another side. So this inclination, it should be equal, right? So if I am considering it, this value as beta, and if I am considering here this value as alpha, can't we not see that 2 alpha plus 2 beta, the total, it should be equal to 360 degrees. Or can I not see that alpha plus beta, it has to be 360 upon 2, 180 degrees, right? So with this, I know that alpha value and internal angle, I have shown you that alpha it is equal to 135 degrees. So what is the measure of that beta, that is angle AFG? That has to be 180 minus 135. I can say that measurement, it will come here as 45 degrees, right? So measure of angle AFG, I can say it should be equal to 45 degrees. And that brings conclusion to this question and its explanation here. The measurement has to be 45 degrees, right? Okay, so that way we have considered questions from polygons in this first phase. So any doubts or any queries, feel free to let me know. Thanks for watching.